Good afternoon, everybody. Thanks for joining the last appointment with the full 2024 Rome Talk series. And today we have a completely different topic from the one we hosted so far. And this lecture is entitled Exploring Generative AI Foundations, Challenges and Ethical Consideration. And it will be delivered by Giuseppe Mastrandrea, that's here with me. Giuseppe is a computer engineer with a strong specialization and publication in the field of computer vision, a developer and machine learning specialist. Since 2017, he has dedicated to teaching and training in computer science, as well as providing education on emerging technologies. So I leave the stage to Giuseppe, and let's enjoy our talk.
So, good afternoon, and thank you for the kind presentation. I am Giuseppe Mastrandrea. I am a computer engineer, a software engineer. I studied... Oh no, now we're going to explode. I studied at Technical University of Bari, where I graduated with a work on human-machine interaction. I have 10 years experience as a developer, as a front-end developer, actually, first, and then as a front-end engineer. So my world of appearance, of belonging is the web development. Since 2017, I started to work in public schools as a programming teacher, a computer science teacher. And in 2020, during the pandemic, I switched back to my first love, machine learning and artificial intelligence with Data Masters. I am a core team member at Data Masters, and now I work on our LLM projects, which are the models that nowadays we identify with generative AI. And I teach in several courses about data science, machine learning, artificial intelligence, and generative AI. So we are going to talk about generative AI today in the next 40 minutes or so. But before we get to generative AI, we must start from the very beginning. So let's make a step back and let's try to understand what really AI is. My question here is, does there exist a formal definition of AI? And it turns out that this statement, this question, is not that obvious. And in this work, Universal Intelligence, a definition of machine intelligence by Shane Legg and Marcus Sutter, the very first statement of the paper is this one. A fundamental problem in artificial intelligence is that no one knows what even intelligence, normal intelligence is. There is not a formal definition, a scientific definition of intelligence. We can recognize as human beings another human being that is intelligent, that we can call intelligent. As we can recognize easily friendship or love, we can recognize intelligence, but there is not a formal definition of it. And to understand, to testimony how hard is this apparently simple task, let's rely on Wikipedia, which is the most democratic source of knowledge that I know. And Wikipedia states that artificial intelligence is the intelligence demonstrated by machines, in contrast to natural intelligence that is displayed by humans. Thank you, Wikipedia, for this totally pointless definition. This is technically a tautology. It simply restates a distinction without providing further details and without providing any meaningful insight into what intelligence could be for machines. The real question here is another one, in my opinion. And the real question is, what does it mean for a machine to be intelligent? This is a pointless definition. So let's start over. Let's start again from the very, very beginning of the field of artificial intelligence. We don't have a formal definition, an academic definition of artificial intelligence. And luckily, this is not really a big deal. To truly grasp and understand AI's potential, we must return to the roots that that we can find in the Dartmouth Summer Research Project on artificial intelligence. This was the groundbreaking conference that really marked the birth of AI as an academic field of study. And I guess there are not here in this room computer science students, but if they were here, they could easily recognize some of the people that are the godfathers of many disciplines related to computer science. We can find Claude Shannon, which is the father of information theory. We can find Herbert Simon, which is a Nobel Prize for economics. Arthur Samuel, who invented the term machine learning. John McCarthy, who invented the Lisp programming language. We have a bunch of guys that were very, very important for the development of the technologies that we use every day today. And their goal, the goal of these scientists, was to find a solution to the problem, can machines think? And they were going to answer, they wanted to answer to this question in just 2 months. This goal was far too ambitious for the short term that they gave to themselves. The complexity of this task extended far beyond the original time frame of 2 months. And the definition that they gave for artificial intelligence is this one: making a machine behave in ways that will be called intelligent if a human was so behaving. So the behavior is the main focus for this current definition. For the very first time that the world encountered the term artificial intelligence. And behavior is something very smart to work on, because it allowed researchers and practitioners of AI to frame this discipline in terms of observable outcomes. And that was very, very important. Now, the original definition has to do with behavior, has nothing to do with thought. The problems that the machine learning models and artificial intelligence models are supposed to solve are a variety of problems, and that's what and that's how we use today artificial intelligence. More on this later. And it wasn't the first time that someone raised the question whether a machine could think or not. In 1950, Alan Turing, in another seminal work for artificial intelligence, Computer Machinery and Intelligence, he started the paper with this question: can machines think? And he proposed the famous Turing test, which is still a practitioner framework for evaluating machine intelligence. He suggested that a machine could be considered intelligent if it could engage a conversation indistinguishable from that of a human. So if a machine can trick another human observer, then we can talk about artificial intelligence, then we can talk about a machine that can think. Both perspectives focus on observable behavior, something that we can measure, something that is objective, that is not something philosophical. We can measure a concrete outcome, a real outcome. On one hand, the Dartmouth definitions emphasizes the behavior of a model that will be called intelligent if a human behaved in the same way. On the other hand, the Turing test challenges machines to replicate human-like interactions. This is a shared viewpoint that underscores the origin of the AI that we know today, the so-called pragmatic AI. So we understand that the only relevant aspect in AI is succeed in a task. And this leads us to two souls of artificial intelligence that are facing each other. The engineering soul that focuses on practical outcomes, practical solutions, very focused on narrow tasks. And on the other hand, we have the fascination that belongs to human beings, that we can model in a mathematical way thought. So, while the first approach leads to the so-called task-focused AI, the second approach, the second soul, leads to process-focused AI. Task-focused AI, also known as engineering AI or weak AI or narrow AI, has achieved incredible successes in almost every field in the last 20 or 30 years. And if we think about language model, for example, if we think about ChatGPT or systems like AlphaGo or systems that are capable of playing chess, these are all models that belong to this first category. So task-focused AI has really revolutionized industries by excelling in specific domains. While on the other hand, process-focused AI, also known as cognitive AI, strong AI, or in its sexiest form, AGI, artificial general intelligence, has a far more ambitious goal, which is replicating human-like reasoning, human-like learning, human-like adaptability across diverse tasks. But it has yet to achieve any significant results, any significant breakthrough. These paradigms highlight a very important contrast in AI development. Narrow AI nowadays dominates the world. AGI represents a frontier that appears to be still very, very far away. So talking about task-focused AI, this is a very common classification of artificial intelligence systems. A series of subsets that shares something in common. And on the parent set, on the parent circle, we can find the good old-fashioned artificial intelligence algorithm or legacy artificial intelligence algorithms. If we have to think about these algorithms, let's think about them in a way that an agent that can play something. So for example, let's play tic-tac-toe. How are we supposed to play tic-tac-toe? If we want to be sure that we will win, or at least that we will get a draw, for every game situation, we have to draw in our minds all the possible moves. And then for all the possible moves, we have to reiterate the same process. The goal is to find the path in this tree of possible moves, of possible outcomes that leads us to the victory. And that's exactly how legacy artificial intelligence algorithm works. This algorithm in particular is called Minimax. And to this category of artificial intelligence algorithms belong models that can transform a problem in a known data structure and then can find a way to find the shortest path within this data structure. Machine learning is the first subset of artificial intelligence that is worth talking about. If we talk about machine learning, we talk about data. We enter the realm of data. So when we talk about machine learning, we talk about models that can learn patterns from data. Models that can study data during their training phase. So we have a totally new concept, the training phase of a model. And during this training phase, basically what a machine learning model does is find the best mathematical formula to resolve a problem. In this case, in this slide, we have highly correlated data, and the machine learning engineer, so the Giuseppe Mastrandrea, once he has studied the data and has noticed this high correlation, decides what mathematical formula is the most convenient. In this case, given this data, a good approximation of the data could be just a straight line. And this is called a linear regression, which is the hello world of machine learning, the simplest model of machine learning. And what a machine learning model does during its training phase is getting this parameter M and Q and iteratively tries to find the best values for this parameter M and Q. These are the parameters that the model tries to learn. When we talk about deep learning instead, we are talking about much more complicated models that rely on neural networks and deep neural networks. Networks are mathematical models that have a very, very complicated formula. And the kind of problem, the type of problems that neural networks and deep neural networks can resolve are much more interesting than the one that we saw earlier. A deep learning model, for example, is a model that is capable of recognizing our face. So if we think about the Face ID of our phone, inside our phone lies a deep machine learning model that is capable of recognizing our face. Or another very common task is the autonomous driving. So a car that is capable of driving in an autonomous way has a deep machine learning model inside it. And then we arrive to the last, to the most, to the innest subset, which is the generative AI subset. Nowadays, the state-of-the-art machine learning models that can generate new data are called large language models. And they are the core of all the models that the web platform that we can see in this slide. So we can find OpenAI with ChatGPT, Gemini, Midjourney, which is a text-to-image tool, Runway, which is a text-to-video tool, Llama, which is the first attempt of making of creation of a open source LLM, Copilot, which is the ecosystem, the Microsoft ecosystem for generative AI. All of these models, all of these platforms rely on large language models. Large language models is the very foundation of the generative AI. Nowadays, they are the core of every single platform that makes use of artificial intelligence to generate new content, brand new content. The success in the conversational interface that can be used to succeed in a series of tasks is the major trait, is the major feature of LLMs. And the architecture they are based on is still deep neural networks with much more complicated add-ons. They are very, very big models, and we will understand what I mean in a while. And the bigger they are, the more data hungry and resources hungry they are. The success of LLMs heavily relies on vast amount of high quality data, high quality text data. And on the other hand, we have a very high demand of hardware and software resources. So we live now in the best possible epoch to train and to use this kind of models, given the big data, given the low cost for cloud computing resources, etc. The core model architecture is called transformers. Transformers was the very was a game changer in the field of artificial intelligence and machine learning. We can see here how a transformer is made. We are not, of course, interested into the details. We will just give a few information on how LLM works. So a transformer has basically two main components: an encoder that processes the input sequence, the text, the prompt that we supply the model with, and it transforms this prompt into a numerical form, a numerical representation that is capable of capturing the meaning of the prompt of the input for the machine learning model. And then we have the decoder part. The decoder is where the magic happens, basically. The decoder is the one that generates the output sequence step by step, token by token. A token is not an entire sentence, is not an entire word, it's just a piece of a word. And the way these pieces of words are generated is purely statistical. So step by step, in an iterative way, the decoder part of a transformer and the decoder part of a large language model simply calculates, computes the token with the highest probability to be generated. And this poses a series of questions. So a transformer and a language model basically does not give us the right answer, but the most likely to be generated. And that's the very first thing that we have to know about LLMs and how they generate data. And when they give us wrong data, we talk about hallucination. And hallucination are, by design, a feature of large language models. So large language models can hallucinate, can give us wrong content. And they can give us wrong content because the only way they have to generate the output is a statistical way. Okay. Let's talk now about GPT models. GPT models are the basis of ChatGPT. ChatGPT is maybe the most famous platform of generative AI. It got public in 2022, just 2 years ago. But ChatGPT didn't come out of nowhere. The very first GPT model, where GPT stands for Generative Pre-trained Transformer, was released in 2018. And internally, it was a relatively small model. It contained 120 millions of parameters. Do you remember when we talked about the mathematical parameter that are learned during the training process? Okay, GPT-1 had to learn 120 millions of these numbers during its training phase. And to achieve this goal, it had to train on a very, very huge dataset of texts. Then 1 year later, we are in 2019, the second version of GPT, GPT-2, was released, and it had a different order of magnitude for what concerns the number of parameters. It was a much bigger model, 1.5 billion parameters. And then just 1 year later, GPT-3 came out, and GPT-3 had 175 billions parameter. GPT-4, that was released in 2023, has an estimated number of parameters of 1 trillion of parameters. And today, the most advanced GPT models are GPT-4o and GPT-o1. And for these models, we just don't know. We don't have this information. But we can argue that these models, the very last models, are even bigger than GPT-4. Now, to test out the different versions of GPT, let's make a test. Apologies for any Italians in the room. Complete the sentence. Italy is. GPT-1, Italy is a foreign country. I don't agree. I do not have more experience with the language. My friend here has never heard of such a place, which is a grammatically correct sentence, but it's totally nonsensical. GPT-2, Italy was a great country until it wasn't. I agree, GPT-2. So we have a more complicated response, maybe nonsensical response even in this case, but we have we have a more structured response. But still, GPT-2 doesn't have the notion of context. And then GPT 3.5, which marks a significant step forward. Italy is a beautiful country, thank you, known for its rich history, delicious cuisine, and stunning landscapes. Okay, GPT 3.5, I agree with you. Here we have the notion of context. So GPT 3.5 understands that we are talking about a country, a geographical country, that we want a general definition in just one sentence of this country, and it just gives us the result. GPT-4o instead write a mini essay on Italy. It's by far the best model at accomplishing these tasks, and it represents a near human level of fluency, a near human level of comprehension, and it showcases that LLMs and GPT in particular have evolved in a very important way in few years. Now, I understand that we might be tempted to ask ourselves this question. So, are language models really intelligent? But the problem with trying to assess intelligence in this manner is that it confuses the output of an AI system with the process, with the mechanisms, the mechanism that the system took to get there. And the dilemma is the one that we saw earlier, process versus task. We can use this skill-based assessment for humans because we know that in humans, this ability to demonstrate, to show significant skill in an area is reflective of an underlying skill of intelligence, of generalization. But machine learning models, they don't work this way. They just try to optimize a mathematical function. They optimize their training goals. So the mistake is thinking that this path required to learn skills for machine learning models, including language models, requires the development of what we call intelligence and what we recognize as intelligence. This is known in artificial intelligence and the machine learning world as the Kaggle effect. Kaggle is a platform, is a website in which data scientists can compete to develop the best machine learning model for a very specific task and a very specific data set. These models often, the models that win the competitions are very good at the tasks they are designed for. They perform exceptionally well in this task, in the narrow task on the Kaggle dataset. But as soon as we try to feed them with new data that the model has never seen, they fail miserably. In machine learning world, this is also called overfitting. It means that the model just learned very well its training data, but it is not able to generalize on new data that it has never seen. And the same is valid. The same statements are valid for language models and their training. They train on data, on a very vast amount of data. So they have a knowledge base that is very, very huge. And it's very easy that when we ask something to ChatGPT, what we are asking is present in the training data. So it is very highly likely that the model can answer well to our questions just because it already knows where the answer is. But large language models, just like the Kaggle competitions models, just don't generalize well when we ask them something they are never seen. Again, hallucinations. There's this great example that was circulating on Twitter around the time the GPT-4 model came out. There's this guy called Horace He that tested GPT-4 with some coding problems. Coding problems taken from a website called Code Forces. And what he showed he conducted this experiment. So Codeforce is a very useful platform because for each single coding problem associates the date in which that problem was created and the date in which it got public. So what Ors he did was collecting 10 puzzles that were released at the time the GPT-4 was being trained. So potentially these tests could have been inserted in the training data of GPT-4. He ran them through GPT-4, and unsurprisingly, GPT-4 got all of them right. And this led all the developers, including me, to panic attacks. Okay, we're losing our jobs, we will not work anymore, AI will replace us, which is a statement that is very common nowadays. Then he conducted the second part of this experiment, and he collected another 10 puzzles that were released after the release of GPT-4. And he ran them through GPT-4, and this time GPT-4 got every single one of them wrong. So this shows that even large language models are not able to generalize. Another researcher, this researcher asked explicitly to GPT-4 if it knows that some of the problems it was tested and it was trained on. And unsurprisingly, GPT-4 gave to the researcher the complete URL showing that of the challenge, showing that that challenge had been inserted in the training data of GPT. So this is a very interesting example, a very simple example, but very effective, that shows that these skill-based assessments can be misleading if applied to language models. Instead, it's better if we look at how well these systems can solve tasks that they have never seen before, thus how well they can generalize. Generalization is a crucial concept in the intelligence and artificial intelligence fields. And this classification, this spectrum, that is the same that we can find in this paper on the measure of intelligence by François Chollet, shows 4 levels of generalization. So we have absence of generalization, no generalization, that includes systems that know all the possible outcomes for a particular, in advance, for a particular task, for a particular problem. Tic-tac-toe, the model that can play tic-tac-toe, is an example of no generalization, of absence of generalization. Local generalization is where we are today with machine learning and artificial intelligence, even large language models. With local generalization, we mean the ability of a system to handle new points from a known distribution for a single task or a well-scoped set of known tasks. So, a model that can perform well on tasks that are very similar to the ones it trained on is an example of local generalization. And under this umbrella, we can find pretty much all the models that we use today, even generative AI models. Broad generalization or flexibility is the ability of a system to handle a broad category of tasks and environments without further human intervention and handle situations that could not have been foreseen by the creators of the system. An example of broad generalization is the autonomous drive, or a machine that is capable of preparing a cup of coffee in an unknown kitchen, in a random kitchen. And we have the very last level of generalization that is called extreme generalization. I read from the paper, this describes open-ended system with the ability to handle entirely new tasks that only share abstract commonalities with previously encountered situation. And under this definition, we can find biological forms of intelligence. So human intelligence or extraterrestrial, we don't know, kind of intelligence. So we have to, in light of everything we have discussed, generalization, specialization, the current capabilities of large language models, we can state that the real sectors, the real tasks in which LLMs shine are the classical natural language tasks. So we can find translation from a language to another, which was the original scope of the transformers architecture. We can find summarization, so condensing large text into shorter texts, text classification, question answering, structuring, organizing unstructured information in structured formats. These are the tasks in which we are sure that large language models really can achieve incredible results. And I want to point out that these tasks are tasks that we are fully capable of doing. But language models can, make us faster in something that we are already good at. And that's the main point of language models nowadays. We shouldn't use them as a source of knowledge. We should use them to support us in these tasks. So in the last part of this talk, I want to discuss with you a couple of real-world examples that show the potential and the challenges of machine learning and generative AI systems. The first example that I want to share with you is Amazon hiring AI system. In 2014, Amazon developed this AI system to automate hiring. The problem was that the AI, after a few months, exhibited a clear bias against female candidates. And Amazon did investigate on this problem, and it discovered that the cause of this problem was that the data the model was trained on was dominated by male candidates. So there was this unbalanced data set that influenced in a negative way the results of the model, the predictions of the model. In 2015, Amazon attempted to fix this issue, but a couple of years later, Amazon abandoned this project because it was just not possible to get rid of this bias. Amazon was not capable, Amazon, not a small company, Amazon, was not able to deal with biased data. Bias is another very important concept for artificial intelligence and machine learning world. And generative AI is not is also can also mislead generated data and can also generate biased data. In this article that is called "Humans Are Biased, Generative AI is Even Worse" by Leonardo Nicoletti and Dina Bass for Bloomberg, they just showed that a library of generative AI called Stable Diffusion amplified racial and gender stereotypes. When asked to depict workers in highly paid fields, generative AI basically created images of white males. While low-paid or caregiving roles were frequently associated with women, with people of color, and this, of course, reinforced societal stereotypes. This is a test that you can do with a random text-to-image model. If you try to prompt this model with a simple prompt, for example, generate the image of a bride, you will get a Western bride, arguably an American bride. You will not get an Asian or a Muslim or an Indie bride. This is another example of bias, bias in the training data. These models, Stable Diffusion, DALL-E, are trained on very large data sets, and these data sets often reflect historical and societal biases. And this is a very important theme, a topic in the world of AI and generative AI. So, LLM, the key points for this lecture are the LLMs, like any other AI tools, are powerful but still limited models. AGI is still very far away, despite of the claims of the CEOs of Anthropic and OpenAI. We are very, very far away from the development of an AGI. And of course, like many other times in the technological history, the trick is that we have to use the right tool for the right use case. Does it sound familiar to you? This principle applies to every single technology we have ever built, and AI is not an exception. The very interesting question that we have to ask in the future regard the capabilities and the respect of the limitation and ethics of the generative AI system and the AI system in order to be used in an effective way by human beings. Any questions?
Okay, guys. Can you hear me? Okay. Okay, I think that, I mean, I'm an olden age woman, so for me, this is like all new. And I don't know how much is going to be used by me, of course, but we're going to try because tomorrow we have a workshop. The thing is, yesterday, it was yesterday, and then or Tuesday, I don't remember, when I said it would be wonderful one day if artificial intelligence may be able to do my washing, and then I will have more time to do my studies and research. So I'm not also, so narrow-minded to think that we cannot use these tools to obviously make our life easier. Obviously, it's, I don't think, and you also made your point, that this is going to be to replace the human intelligence. We have to feed this intelligence to make ourselves more comfortable.
Yes.
So that is something that I agree with, because we can use more time for more interesting things as a humans, even for our spare time,
Yes.
which obviously it's very important too. So, but students nowadays, that's why I stopped asking essays, because I wasn't able to
ChatGPT.
detach. Yeah, I wasn't able. I mean, I wasn't able to detach sometimes. The use of AI, and so I decided to go back to projects so I can see the development of the project, because for me, what is interesting, it's how a student develops a project and not how the project is actually made. It can be beautiful, but for me, it's better a less beautiful project that has a very strong developing process than the other way around. So, but I was actually very curious to hear from you, because you are the digital natives that probably are in the shift of these two way of being. I can just have some little aid, but I don't think that's going to change my life completely. I am, very resistant to any change. This is the moment of my life, but probably not. So I will be very interested to hear from you. How do you feel as a student, with the use of these aids? Also, you have different disciplines, because some of you are architects and some others have a different background. So any comments you want to share?
I just want to point out, don't feel like you're cheating if you use ChatGPT, because we were saying earlier that uh, it is a new level, it is a new base point. Then the human touch comes, and that's what enriches projects.
Depends on the, because I mean, for example, if there is a reflection paper, so if you have to put input on the information, that is fine. If we have to evaluate the nature of the writing, everybody has a writing style, so obviously that doesn't fit. But I mean, once again, I don't want to be narrow-minded, but I will hear from you. What is your relationship with that?
Well, I was just gonna make a comment on was it last semester we had an AI, like we talked about AI a lot. I think it was last semester. And it was interesting that we thought of AI more as like this tool that you're discussing, and especially within like we're architects over here, so like using it in the design process rather than an output, thinking of more of it as like it's an input that then we take our own ideas based off the input it's giving us. So in that aspect, I think, at least for me, I think of it more as a tool right now. Obviously, there's so much like I don't know about it, and so much we don't know about it still, but it's been very helpful in the design world. And like when we're stumped and like don't know how to start something, it offers so many different like disciplines, and so that's been very helpful. And then on the reverse side of things, I did an activity freshman year where our professor gave us AI generated images, and we had to, and they were crazy. Like they had things in them that made no sense. And we actually had to analyze them and try to figure out what inputs were put into the image to generate that image. So it's kind of interesting how it can be used in the reverse, where we can
Yeah.
use it for
Yeah, it's very
inputs, but then
interesting.
also use it in the reverse for starting with the output.
Yeah, it's
So.
a sort of reverse engineering of how machine learning models think and generate outputs. Yes, it's very
Yes.
interesting. Very interesting. Yeah, exactly.
Yeah.
Yes, yes.
Thank you. Anyone else? Okay. Eccolo.
I guess it's more of a comment than a question on AI. The way I've always kind of viewed it is as a better form of like Google. Whenever I go to like the large language model like ChatGPT, it's like I can have an interaction. If I don't know what I'm trying to learn, like I'm trying to solve a problem and I don't know exactly how to solve it, it's a lot easier to have a conversation about it and solve that issue than by just randomly searching a couple keywords into a search bar. And so I've always found that like pretty useful with AI.
Yes, it's pretty well. The conversational part is the fundamental part of generative AI systems, and it really depends on what you mean by I use ChatGPT as a search engine, because it is not the right tool to do a standard search. For example, I want to buy something, an object, then I ask ChatGPT to do a search for me. No, that's not the case. There are other tools, even conversational tools. Perplexity.ai is one of the tools that works best for this use case. But to have a grasp of a topic, it's a very good form of research. I totally agree with you. So to have a first idea about a topic, I use to ChatGPT this way. Give me some basic concepts about a topic, and that's very useful. But if you try to use ChatGPT as a pure search engine, it's not the most useful tool. There are tools with generative AI that work with generative AI that are far better than ChatGPT. Perplexity, give it a try.
Yeah. Thank you.
Anyone else?
Sì, c'era lei.
Okay, eccola.
Yeah, so I used Midjourney over the summer
Okay.
at my job, and it was interesting to see how like new versions would come out because as people were using it, it was like learning more and like getting more information.
Yeah.
So I noticed how like the quality of images that were being produced like was a lot better because it was like learning as people were using it. and also how like the older architects at the firm kind of didn't like it because they felt like it was going to replace their jobs in terms of like renders and like mood boards and stuff. And then all the younger people were like really excited to be using it. It was just interesting.
Yeah, it's very interesting because according to many researchers and professionals, we will not be replaced by AI. We will be replaced by people who know how to use AI. And Midjourney is a wonderful example of this statement. And I want to point out another thing, one last thing, is that these models are data hungry. We were talking about that before. And the more AI generated data, and the more this data will be fed into machine learning models. And this will lead at a certain point to machine learning models that train on data generated by machine learning models, which is a sort of
Inception.
shortcut. And this is another interesting topic in the research in the field of machine learning.
Okay, no, I don't have the fear. I mean, obviously, as a researcher, I don't have this fear, but I'm very tempted in the way, as an instructor, you know, you can give, for example, for me, doing PowerPoint is the most annoying things that you can possibly do, because you have to collect the material and then the image, they have to be nice looking, and it's all a lot of waste of time that you can use for doing more viable things. So if that is something that can help me with my job, I will be very happy. Of course, I am the one that has to give the data and have to check them, because obviously it's not possible. And this is also for your say. You can ask anyone to, I mean, you can ask a machine to do that by feeding the data, but then you have to fact checks, first of all, the
Yes,
sources, and
always.
that doesn't do that for you. Okay, sources are important in anything in life. A rumor can be wrong or right, and we have to check where the rumor comes from, and that is the first thing. Secondly, we have to see if the machine has processed properly. It's like when you do the translation on Google Translate. I do all the time because I teach in English, which is a different language from my native one. So sometimes if I'm obviously tired, I use the translator, but I have to check it 2 or 3 times to see if actually the meaning corresponds. So that doesn't exonerate us from checking the final product. And once again, starts with the humans and with the human.
Yes.
Okay, let's thank once again our guest.
Thank you, guys. Thank you.
Thank you very much.